Hi, it's Dave. It's Friday, May 15th. I'm going to run through the optimizer tutorial fairly quickly on a YouTube video here, as I promised I would do in class. So I'm working off of off the Extend Help manual, which is on the left-hand side here, starting on page 647, which is 686 in the PDF file. We're going to run through the optimization block. I have located under the examples how to file an optimization folder in Extend 9, the optimized 1.mox file, which, as the manual suggests, I have renamed as my optimized 1.mox so as not to corrupt the original file. Additionally, I've gone ahead and added a notebook to this to put some key parameters in it, and I've opened the library value. This model represents a beverage operation where customers arrive according to a log normal distribution and they buy drinks. There's a certain amount of drinks available. It's replenished from a filler truck periodically according to a table. 1,000 drinks come in every 240 minutes. And that's the initial values. And then the drinks are consumed and they run out of drinks, and then people are turned away until the tank is replenished, and then they sell more drinks. Graphically, what's going on can be seen here with the red line is the total sales, which they sell drinks while they can. They run out, it lays flat. The tank gets refilled, they sell more drinks, and then it lays flat. And the amount of drinks in the tank is the blue line, and they run out, and then nothing happens. The green line is how much cumulative time the tanks are empty. And there's going to be an opportunity cost built into the model in terms of what happens when you've got a drink set up, drink or enterprise set up, but you're not selling anything, you're starting to incur costs. Okay, so let me just run through and let you see how the model runs before we start doing any optimization. As you can see, time goes through, they run out of drinks, their empty time's accumulating, gets refilled, and run out of drinks again, and there you have it. You can change the size of the tank according to this table when it's replenished. Instead of 1,000, we could make it 2,000 drinks come in for the resale, for example. And then when we run the model, we see that they sell 2,000 drinks, and then there's less waiting time. And at the end of the time, they've sold 4,000 drinks, and their empty time is less, but it's still not great. All right, so there is an economic model associated with this that's described in the screen on page 650. It says basically that, is that the profit that I'm making is equal to $2.50 times the number of drinks I'm selling, must be some sort of alcoholic drink, minus the costs. And the costs are, it's $1,000 every time the truck pulls up just for the delivery, times $1 per drink inside the truck. So that's the cost per delivery times the number of deliveries. There's an additional cost for every minute that you're running empty, you lose $100. That's the must be a very big bar, but that's the notional profit. So the question is, how frequently should the truck arrive, and what should the size of the truck be to maximize the amount of money we make? Now, we could hunt and peck through here trying to find different combinations of values to see what gives us the best return, but that's been automated for us using the optimization routine. So let's talk about how that happens. We're going to add an optimization icon to the model, optimizer here out of the value library, and pull it in. When that opens up, there's two parts to this. There's variables that we enter using the clone tool, and then there's an equation that we try and maximize. There's some run parameters that get set up, but basically the extend will search through the various values of the parameters that we put in within the ranges, maximum, minimum that we specify, and we'll try and find the settings that maximize the profit equation we hear. Extend's kind of funny. It either says max profit for the objective to maximize something or min cost if you're going to minimize it. We're going to do a maximization problem here. Okay, so let me close out of this for a moment. So to fill this, if we scroll down and look, we want to add some variables. And the first variable we want to add is the number that is sold. So to illustrate this, we go to total sales block, which is keeping track of our total sales. And we're going to use the clone tool right here. We're going to select that value for the total sales, and we're going to just drag it and drop it into the clone block. When we do that, it asks us for a name. And to make life easier, well, we'll come back and name it here a little bit easier, but it's going to be total sales. We'll just put it in right now. And we'll just leave no spaces in there. It makes things easier later on. Okay? All right, that's our first one entered. Next thing we have to do is the number of deliveries. We don't have a field here that shows the deliveries, but we do have one that shows the time between deliveries every 240 minutes here in my table. So what I'm going to do for that is, bring this over a little bit, drag and drop that again using my clone tool, and put that. I'm going to call this one I'm going to call it delivery times. Okay, click that in there, and now that one's in there. The number of drinks I put in comes out of the filler truck. Here I can't get that one number in, so I have to use the clone table and drag the entire table in, but we'll use that for, we'll see how to pull a specific cell out of that here in a moment. Okay, and then the time empty, so if I go to the empty time, and I go to the total empty time, pick up my clone tool again, and drag that in. These are going to be my 4 parameters, and we'll just put time empty for the variable name. Okay, so those are all the things I'm going to need to enter my equation in. All right, moving to page 652. If I open the optimizer block, okay, I can see I've got my variables here. They're named, where they come from is identified. So the first thing we're going to do, we're not going to enter any limits on total sales because we're not going to be searching total sales. That's an input. On the second one, we're going to say that the most frequent interval for reloading is going to be 30 minutes, and the maximum is going to be 480, which is the time of the simulation. Okay. For the filler truck, we have to say which data point that we want to fill out of that. So if I click on the data table, I can see that the cell that has the number of drinks is row 0, column 1, remembering the way things are noted. So I'm going to remember that, close out of this, and I'm going to type in the row and the column here, 0, 1. That tells where we can get the size of the drink tank, put it in, and we're going to say it's at least 1,000 drinks and it's no more than 8,000 drinks. And again, I'm getting those numbers from reading in the table. Okay. When I don't put a decimal point in, it says that the values are going to be in integers. So that's not critically important, but we'll do that. So the empty time, again, that's a model output, and we don't have to put any limits in it because it's not going to be searching that. Okay, down below is where I put my objective function. And my objective function, which I'm just reading off page 652, is going to be equal to 2.50 times the number sold, which I've here called total sales, just to confuse you. I have to match what's on my screen, not what's in the book. Okay, so that's the income. And my costs are the number of deliveries, which I'm going to come back for. I'll come back and substitute for that in a minute, times, it's $1,000 per delivery, plus it is my delivery tank size, which I've called filler truck for some reason, times $1. Okay, so that's the cost of bringing the stuff in. The number of deliveries at $1,000 per delivery plus the number, the size of the truck, number of drinks in the truck times 1. Okay, and then my cost for it being empty is time empty, using the nicknames I did. Back to my caps, times 100. And these always end with a semicolon. Okay, so the only thing that's missing here is the number of deliveries. I put a placeholder in for that. So the number of deliveries, there's an explanation in how we convert the reciprocal of the delivery times into a number of deliveries using an integer calculator and some rounding. We're just going to put that in. There's two ways to do it. I could put this actual formula just into the equation, or I can set up a intermediate variable, which I'm going to do, which says I'm going to define as deliveries. I'm going to say that's equal to the integer of end time, which is a system variable, says when simulation ends, minus 1, divided by my delivery times, plus 1, close parentheses, semicolon. Okay, so that defines what deliveries are, and I'm just going to take that little asterisk out of that and put that in here for my overall equation. So I've defined what my deliveries are, it's an intermediate variable, and now I've got just checking I've spelt everything right. I've got it in there. Okay, so again, I'm just quickly running through what we have here, and I think we're straight. All right, and so now all I can do, go to the block dialog, go to my run parameters, and I can do quicker defaults or better defaults. We'll start with just quicker defaults. It's a random model because we have a random block for arrivals. We'll show the plot during time, and we'll just accept the parameters there. And let us click new run and see what happens. Undefined variable. The identifier deliveries is a user-defined variable. Let me come back to that and see what I did wrong here. Deliveries equals delivery times plus 1 semicolon. Let's see if changing capitalization makes a difference here. Oh, I have to define the variable, so I left off the definition what the variable is, so I have to put integer. It says I'm defining an integer, and I'm calling it deliveries, semicolon. So that's why it's missing. If I'd followed more closely with the book, I'd have picked up on that. Okay, so now we run it, and what's happening is we can see it's going through all these different runs here on my notebook, and it's changing what the various values are. But what also we can see here in the results column is it's sampling various delivery times and various amounts of the filler truck, and it's keeping track of what the profits are. And as it gets a bigger profit, it moves it to the top of the list, and it keeps iterating and searching, hopping around until it finds a value. And with my notebook here, I can see how that's actually going, and how each run as it experiments is being done. So you can see the refill times changing here, and I can see the size of the truck changing here. I can see all the stuff that's going through to fix a model. And the book tells us that we should get something that's close to 250 minutes between deliveries. Looks like we're working our way up there, and about 5,200 drinks per tank. And it looks like we're working our way up there, and this takes a while. Could probably make it go faster if I close the results window. That's what the book says. Now let me just close my notebook. That'll make it go faster too. And then it did converge after I closed all those things. And I get delivery times of 246 and a filler truck size of about between 5,080 and 5,100, let's say about 5,100. So that's my approximate. Your answer might vary, again, because there's some randomness in this and we're doing a small quick search. Okay, so that suggests to us what the optimal settings might be. Now, from a practical matter, scheduling this to come every 246 minutes probably isn't going to happen, and to the nearest gallon probably isn't going to happen. So what we're going to do now is add some constraints as explained down here to say that the delivery times have to come in multiples of 30 and the truck size has to come in multiples of 1,000. So to do that, we go to the constraints window. We'll add the comment in here. We'll add it just like it's listed here. Comments, round delivery amounts. Okay, oops, round, spell correctly. Okay, and now here's where I have to try and remember what I called things. The delivery amounts I'm calling filler truck. Okay, so I'm going to say if filler truck is less than or equal to 4,000, I'm going to set the filler truck to be equal to, and here's just a round off integer, filler truck divided by 1,000 plus 0.5, and that'll round to an integer times 1,000. Okay. So that tells me what to do if it's less than 4,000. Otherwise, I'll put an else in that the filler truck will be equal to integer filler truck divided by 2,000 plus 0.5, close parentheses, times 2,000, 0.0, semicolon. Okay. So what this does is it says that my truck sizes will be 1,000, 2,000, 3,000, 4,000, 6,000, 8,000, 10,000. So the sizes go up by 1,000 to a certain point, and then it goes up by 2,000. And that's what we have here for the 1K, 2K, 3K, 4K, 6K, 8K, which is good. And then the other thing we're going to do are delivery times. We're going to round delivery times. If I could type, sorry. Okay, and here we're going to say, what did we call it back here? We called it delivery times. Good for us. We use the same one. So we'll say delivery times equals integer delivery times divided by 30 plus 0.5 times 30, semicolon, and that's going to round everything to the nearest 30 minutes. And I don't need an if here because I've just got the one rule. It doesn't depend on the size of delivery times. Okay, so those are set. Hopefully that'll work. And now if I go back and run it, what did I do? Found, close parentheses, expecting semicolon. Let's see. If filler truck, to the semicolon, else. I have the wrong size, shape parentheses there. Typing is a great killer on this stuff. Any type of programming, you get killed with case sensitivity. Okay, so that should fix it. Let's try it now. Now it's running, and as you see, the delivery times are coming in multiples of 30, and my filler tank size is coming in to the nearest 1,000. The answers we get are going to be a little bit smaller because it's a more constrained model. Anytime you constrain it, it doesn't go as well. Okay, and I can look at my notebook as this goes along, and I can see the various things going through. What I'm seeing is very little green time where I'm not running out of stuff very often. Okay, so it's sort of converged on 6,000. It appears to be the best size for the truck, and it's trying to make up its mind what the best time is, which is looking like 270 minutes. Okay, we'll give it a second to converge. But that's generally all it is. And I can put these blocks in and do my optimization, and life is pretty good. So it's a very powerful tool. I wanted to show it to you using their example. We'll talk about this again next week. We'll wait just a moment here to see what converges. It takes a while to run this, even on a fast computer. Let me close the notebook and close the window. That generally makes things go faster. And it's going a little bit faster as it thinks about it. And it's converged. Now we'll open it back up. And yeah, 270 minutes between deliveries and 6,000 fuel tank size, and gives me results between 10,228 and 10,756. Still some variability in there with the randomness. Okay, good. Hope this was helpful, and we'll see you next week.